Hello, everyone. The purpose of this segment is to discuss basic plotting in MATLAB. How do we do plotting? So let's get started. The idea of plotting is that we have data, x values for the data and y values for the data, and then we plot them against each other. So for example, suppose I have a simple array. Let's say x contains 1, 2, 3, 4, 5. And I have another array y. Let's say it has -1, 2.1, 5, 3, 4.7, and I want to plot the y values versus the x values. So as long as I have them as arrays, then things are very easy. So let's actually get a script here, a new script. Let's save it as maybe basic underscore plotting. Let's define x as an array as we learned by putting these elements in between square brackets. Of course, I could have used the colon notation to write this array, but let's explicitly write it, especially that for the y values, we will have to write them explicitly since the data are a little bit irregular for the y values. So I have -1, 2.1, 5, 3, and 4.7. All right, so these are the x values and the y values. Now I can simply say plot x comma y, save, and run. I get a plot that I can see, but you probably cannot see it. So let me dock it inside the MATLAB window. Now you can see it. Of course, what I did is I docked the figure inside the MATLAB window. I can do undocking by clicking on this triangle here, and I will get a menu, and I have the option to undock the figure and get it outside the MATLAB window. But let's look at the figure. I have basically the x values here, the 1, the 2, the 3, 4, and 5, and I have the data here, the y data appearing here, and that's how simple it is to do plotting in MATLAB. Of course, the figure can be improved a little bit. Let's actually do some improvements here. For example, I can mark the data themselves, maybe by squares. So for that purpose, I need another comma, and between quotation marks, I can put squares. So square is S, or maybe circle is O, or maybe diamonds D. So basically a symbol to represent the data themselves. So let me start with the square. I can also control the coloring of the figure, and for that purpose I can write R red or blue B or black A, and so on and so forth. So let's actually try red here. I can also control the line that connects the data. So I can use dashed line, I can use a continuous line. So for example, if I want a continuous line, let me put it this way. So let's actually test this first. I'm gonna do run again. Again, I have to dock the figure. So now it's docked. You see the data are squares. They are connected by a continuous line, and the line and the symbols are red. So let me actually close it again and do a little bit of a change here. I'll make it dashed line. Instead of squares, I use circles, and instead of red, I will make it blue. I can save and run again. So and I have to dock one more time. Yeah. So yes. So the data are circles connected by dashed lines, and the coloring is blue. You might wonder, how does the order matter here? So whether I put the dashed first or the O first or the B first, in fact, the order here doesn't matter at all. And you might also wonder, how do I know the available colors or the available symbols or the available lines? That can simply be done by typing help plot in the MATLAB window. And all of a sudden, you have a detailed explanation. But in particular, you have B for blue, G for green, R for red, C for cyan, and so on and so forth. You have the available symbols here, and you have the available lines here. You have solid, dotted, dash dot, dashed, and none. All right. So the thing is, these are not the only available colors. You can have more, but at least as a starter, this is good to know. To start by to use the colors that are available by a symbol letter like B and G and R and C and so on. All right, so that's in terms of choosing symbols, lines, and coloring. You can also control the fonts and the thickness and how big are the symbols. But again, this is something you can explore on your own. Let's just focus here on the main things. You might wish to add labels to the data. To label the x-axis, so that I can put here by typing x label, and between parentheses and quotation marks I can put, for example, x values. Similarly, I can label the y-axis y label, and with the same story here, I will say these are the y values. You can also add a title for your plot. For example, I can say this is my first MATLAB plot, something along these lines. So let's save, run again, dock the figure. As you see, you have X labels here, X label, X values, and Y values as a Y label, and my first MATLAB plot as a title for the figure. Let's try a little bit something more relevant, especially if you are using math functions. So I will keep this. I will keep this script, and I will generate another one. Maybe let me save it here. I will call it basic plotting number 2 dot m. So let me save it. So this is basic plotting number 2.m. And in fact, let's try to plot some functions and maybe two graphs in the same plot. For example, suppose I want, let's make another example here. I want x to be an interval that goes from, let's say, 0 to 2 pi. Okay. And suppose you want to plot two functions, let's say y1 and y2. Let's say y1 equal sine x times cosine x, while y2 maybe is sine square x. Okay. Of course, we need to label and put a title, and something new that we will learn is adding a legend. All right, so let's get to coding this. First, x. The easiest way to define the array x is to use either length space or the colon notation. Let's actually try to use length space here. Length space from 0, 2 times pi, comma, let's actually take first 10 points and show that this is really not a good choice because the function will not look smooth. Let's define y1. y1 is sine x times cosine x, but we have to be careful here because sine and cosine are arrays now. And because they are arrays and I'm multiplying two arrays together, I have to put a little dot here, as we learned in a previous video. Similarly, y2, I can define it as sine x and then square. But again, as we said, these are arrays, and now I'm squaring is like multiplying the array by itself, so I have to put a dot here. And finally, to the plot, we have two options. I can say plot x comma y1, x comma y2, and that should be enough. In fact, let's do this test first. I'm going to save and run, and I will dock the figure in MATLAB so that we can see it. You see, I have the blue figure and I have the red figure, but I don't know which is which, right? So that's a little bit problematic. Also, the figure doesn't look smooth. This doesn't look like trigonometric functions, which we are used to be, to exhibit this oscillatory smooth behavior. So probably we can improve things a little bit. The first thing we can improve is the number of points that we are using for the plotting. Instead of 10, let's be a little bit generous and use 100. So let's save, run, and dock. So now you see that the curve is becoming smooth. Now you can do some sort of controlling the colors a little bit so that I know which is which. So for XY1, I'm gonna put let's say make it green with a continuous line. Of course, I can put symbols here, although with 100 points, the symbols will not look that nice. Maybe I can make squares. The other one, which is the sine square function, I'm gonna make this continuous or maybe dashed, red, and circles. So circles is O. So let's actually test this, save and run, and dock inside MATLAB. So you see, so this is the first function, which is sine x cosine x, and the other one is the sine square, which is circles and red here. So yeah, so of course I can keep improving things a little bit. So I can put the X label, and that's actually recommended to improve the figures until you are satisfied with how they look like. So for example, X values, I can also have a Y label, Y values. I can also add a title, and maybe functions. All right. So let's save and run, and dock. So you see now you have the labels, you have the title, which is very good. Let's do something extra now, which is adding a legend, because I want to know which function is which. So let's do this here. I'm going to put a legend. And since I have two graphs plotted here, I will have the first legend, let's say it's sine x cosine x, and the other one is sine x squared. So by the way, I don't need to put a dot or anything, or even a multiplication sign, because this is meant to be read as a mathematics writing rather than as programming or MATLAB syntax. Let's actually save and run and dock again into the screen. You see you have your legend here that says sine x cosine x, and it says sine x squared. You can actually move this around if you are unhappy with where it is located. You can move it around, of course. What else can we do? Of course, you can save your figure. If you see here, there is a save. If I hover with the mouse here, there is a save, and I can save this figure either as a figure, as a .png or .tiff figure, or I can save it as a MATLAB figure. So it's up to you which you can copy it here as an image, and you have several options here to save your figures, and that's something you can explore on your own. But before we end this segment, there is something very important I would like to highlight. If you see here, when we did the plotting, we put the two plots in a single plotting command. But in fact, I could have split them into two commands. In fact, let's learn this other approach. So I will keep this. I'm not going to delete it. I will put a comment here. So I'm not going to delete it. And let me copy this. So I can do the first plot command here, and then another plot command right after. But the problem, this is not going to work. You need somehow to tell MATLAB that there are to expect another plot when you do the first one. And the way to do this is to ask MATLAB, hold on. So you do the first plot, and then you ask MATLAB to hold on, and then you do the second plot. Of course, if you need a third plot, you need another hold on to add a third plot. This way you tell MATLAB that there is another plotting coming in the same figure. All right, so let's actually test that this actually works. So I'm going to save and run, and I can dock it. So you see it works smoothly as a single plot command with the two functions plotted at the same time. It's good to know both, especially this one, because sometimes you have a very long code where in some part of the code you are plotting one function, and then later, maybe 200 lines of code later, you will plot another function on the, or you do another graph on the same figure. And it's good to know that you need to ask MATLAB to hold on before the second one comes. All right. So let's recap. Plotting in MATLAB requires you to define arrays. Once you have arrays, you can do the plot smoothly. You can define these arrays explicitly as we did here. So you see this is an explicit definition of the arrays. And by the way, you have to be very careful in terms of the number of elements. So if this array contains 5 elements for the X data, the Y data array also has to contain 5 elements, or otherwise MATLAB will generate an error. All right. The other option is to use length space function or column notation to generate large arrays, and then use array operations to create the Y data, as we did here for the Y1 and Y2, and then you can do the plot smoothly. All right. Thank you so much, and see you in another video.